Okay, so Chemistry Unit 1, Quiz 3, review. What's the difference between mass and volume? So the mass is the amount of matter in an object or a substance, whatever. And so we can think of that really as the amount of particles. Whereas volume is the amount of space, like how big something is, amount of space an object, which are those particles, how much space it takes up. Okay? Those are not like the specific scientific definitions you might look up in the book, but that's what we need to know. Mass is the amount of matter, volume is the amount of space. All right? The law of conservation of matter, conserving matter, means really the amount of matter before a change equals the amount after. Whatever I start with, I should still have it at the end. When we do modeling and stuff, this is why I say it's important to keep track of the number of dots in your model. So we're moving dots around. I gave an example about like just an ice cube melting today in class. You know, if I had a model of an ice cube melting, I started off with the first picture. I'll just do a square. So if there's 5 dots, that's like 5 particles. And then I have a middle drawing where we start to see some ice cube melting. Well, I still got to have a total of 5 dots in the picture. Okay? And then maybe in the last picture, it's just a puddle with 5 dots. Okay? That's conservation of matter. And what the real definition is that matter cannot be created nor destroyed. Okay, how do we find the mass of an object? So I heard some different suggestions for answers today, but really when we find the mass of the object, we're trying to find the amount of stuff in the object, the amount of particles in the object, the amount of matter. What we're going to do there is we just use a balance of some sort. We use an electronic balance, but I want to make sure that you guys also don't say weight or weigh it. Okay, no, we don't weigh it. That weight is different than mass. We use an electronic balance, but you should know and remember that the units are grams, which are abbreviated with a G. All right. Now, the volume of an object, that's a little different. So if we have what I call an object like this cube over here, I call this a regularly shaped object. And it's regularly shaped because we have a clear one side here, one side here, one side here. We have 3 different sides. We could call this the length, we could call this the width, and we could call this the height. And so if I wanted to find the volume of this cube, then I would take the length and I would multiply that by the width, and I would multiply that by the height, and that would equal the volume. And it's important that we think about units. So depending on how big this cube is, maybe if this was the actual size, I could use a ruler. That would mean that each of these measurements would be in centimeters. Okay, so this would be in centimeters, this would be in centimeters, and this would be in centimeters. And if we take centimeters times centimeters times centimeters, then we're going to get units that are centimeters cubed. Okay, now on number 5, it's not as easy, like maybe this is a cylinder, okay? Maybe we could do the volume of a cylinder. You could try to do like a length times width times height, but you don't have distinct sides. So something like this, we would really just pour it into a graduated cylinder. And of course that would have a little dip in there, so it would dip down a little bit. And where we measure that is we always measure from the lowest point, which we call the meniscus. And again, so it's important to remember here that when we use a graduated cylinder, our units here are going to be milliliters. And then I forgot to put a number 6, it looks like. But so here's how you do measurements. And I was saying today in class, if you were just working in a group and getting numbers and getting answers, that's great for getting points on this review, but you need to truly understand why you're getting those answers. So the way I explained this is if we think about our number places, like I did 3 on each side of the decimal. And so hundreds here, we have tens here, and we have ones here, and we have tenths, and we have hundredths, and then we have thousandths. So what we would do is identify the lowest mark I can see on the measuring device. So if I'm looking at this first one, I might ask right away, can I see like every one? So can I see all the ones places? Like I can see 1, 2. If it continued on, I'd probably see 3 and 4 and 5 and 6 and so on. So the ones place, and I did little smiley faces in class. Yeah, I can see that. All right, or we could do a check mark or whatever. Yep, good. All right. Can I see, now keep working to the right, can I see the tens place? For example, can I see 1.1 or 1.2, 1.3, 1.4, and I'm marking them on here. Clearly we can see down to a decimal place, to a tenth. Okay, so that one's good too. All right. Now, can I see marks in between those? And the answer there is no. Okay, so I'm not going to put anything there. But what this tells me is when I write down my measurement, I should write this place, so I should have something in the ones, or anything bigger depending on the measurement. I should have something for the tenths, and then I should estimate one spot further than I can see. So that's telling me that my answer should have 2 decimal places. So if I look at this measurement here, okay, so it's starting at 0, and it's going right, it's going somewhere between 1 and 2, I know that, so it's going to be 1 point something. And it looks to me like it's somewhere between the 3rd mark and the 4th mark, so that means it's 1.3 something. And now I know halfway between the 3rd and the 4th mark is going to be 1.35 represents a halfway point. Now, I think if I look at it closely here, I think it might go slightly above half, so I might be putting 1.36. Now, you could get something different on this last digit, and that's okay. Really what I look for when I grade this is the number close, and do they have it to the right value, all right? So we do the same thing with the beaker. Can I see all of the hundreds? Well, that might be too big a unit. Can I see all of the tens? So I can see 20, 30s marked, 40s marked, 50s marked, 60, 70, 80. Sure, I can see all the tens. Can I see all the ones? So I can see the tens. Okay. Can I see all of the ones? Okay. I cannot see all of the ones place. If I did it up here on my other chart, so I can see the tens, I can't see the ones. So that means my answer is just going to go down to the ones place. So I know my tens place is between 40 and 50 somewhere. I know that in between mark there is 50, all right? So halfway between that would be 45, and I think it's just slightly lower than 45, so I would probably put 44. All right, and then the last one, so let's see. So hundreds probably too big. We'll ignore that. Can I see the tens? I can see 10. It would probably show me more if the ruler was longer. Can I see all the ones? Yes. Can I see the tenths? No. So that's going to be my point that I estimate to. So my answer should have a tens, a ones, and a tenths. Okay? And it's not big enough to go to the tens place, so I can just really ignore that. So it's somewhere between 2 and 3. And it doesn't look like it makes it halfway, so I'm not going to put 5. Um, so I would put down 2.3 or 2.4 for this, somewhere around there. Again, this last spot is an estimate, so if you have something different, it's not that you're wrong. Okay, so in the lab, what we were supposed to see um, was a relationship. So if I had a regularly shaped container. So what we did was we poured water in, and we knew the length times the width, the base. We did that, and then we measured the height. Okay, and the height came out to be some answer in cubic centimeters that we were talking about above. Okay. Well, when we took that water and then we poured it into the graduated cylinder, we should see that that answer, which would be in milliliters, equals this answer. Okay, so for example, if I did the regular container, length times width times height, and I multiplied those three things together, and the volume came out to be 216 cubic centimeters. When I poured that water into the graduated cylinder, the volume should have been about 216 milliliters. Okay, so what that means, what that tells us, is that 1 cubic centimeter is the same as 1 milliliter. These two units are interchangeable. If I find a volume using a graduated cylinder and the volume is 115 milliliters, I could also just say it's 115 cubic centimeters. And like I said, if I did something, a volume measurement with a regular container and I found that the volume was 475 milliliters, I could also just say it's 400, I'm sorry, regular container would be cubic centimeters. I could also say it's 475 milliliters. We also call those cc's. You've heard that with medicine. All right, so here we have to do a graph. We have to try to determine um, question saying, is there a relationship between grams of fat in fast food and total calories? So we have to, first of all, title our graph. I don't know what we want to call it. We could call it fat versus calories, or um, calories. I don't know. I guess fat versus calories would be good because that's really what we're comparing here. Let me see if I can do this on here. I'm going to zoom out a little bit. All right. And so maybe I title it total fat versus calories in fast food. Something like that. Something that explains what I'm doing in the graph, okay? And so I have to look at my data. I have to try to figure out, oops, what am I going to make the x-axis? What am I going to make the y-axis? And so I ask a question, and just remember that title's there, but it's in my way right now. Ask a question. Does the fat depend on the calories, or does the calories depend on the fat? Which one makes more sense to you in this test? And so I think we're looking at the amount of fat and then seeing how it compares to the calories. So we're kind of saying, does the number of calories depend on the amount of fat? Okay, so that means if the calories depend on the fat, that means calories would be my y-axis. And that means total fat would be this bottom. I might have trouble here with this thing in the way. So that would be total fat. Calories on the side. We always have to include our units. So this is in grams, just like it says in the table. And then for calories, that's already kind of self-explanatory what the unit is. Calories. I could write something like that. Calories. That's what it is. And now, so you have a pre-made graph for you. It's got a certain number of marks here. It's got 2, 4, 6, 8, 10, 12, 14 marks. And so my total fat, I'm going to look at what's the top value I need to go to. And so look for my highest number. I see a 31. I see a 34. So really, I got to go up to at least 34. I have 14 marks to do so. So if I did each one for maybe worth 2 grams, that would take me up to 2 times 14 would go up to 28. That wouldn't be enough. If I did each one was worth 3 grams, I could do that. That would take me up to 3 times 14 would be 42. That would be pretty good. But 3 is not a very fun number to go to, use. I like numbers like 1, 2, 5, 10, 25, 50, 100, 125, 150, 200, things like that. So I kind of like to work in at least 5s. That might be too much here, but we'll try it. So I'm going to make the first mark worth 5, 10, 15, 20, 25, 30, 35, 40, and that's probably going to be enough there. And then the calories, I have to go up to, I see 560, 590. Basically, I have to go up to like 600, okay? So there I have 2, 4, 6, 8, 10, 12, 13 marks showing here. So if I got to go to 600, I could always do some math and go, gotta cover 600, and I've got 13 marks to do so. Just do some math. So I take 600 and divide by 13, and it comes out to be 46.15. Now, figuring that out tells me that I could make each one worth 50, and that might work. All right. And if I'm ever worried about running out of room writing my numbers, just number every other one. So instead of marking every mark 50, just mark every other one 100. Okay, so now we plot our data. And the first one is going to be 9 grams of fat, 260 calories. So where is 9? Maybe somewhere around here. And I got to go up to 260 calories, so somewhere right above, maybe about there. All right. We've got, and I'm just going to do a few of them, otherwise this will take a long time. 13, 320. Maybe I'll skip a few. Let's go down to quarter pounder with cheese, 35.30. You should do every one. So quarter pounder with cheese is 35.30. So here's 30, and then 30, go up to 5.30. So somewhere around there. All right. And then I've got the Big Mac, 30. Let's skip another one. 31.550 for the Arch Sandwich Special. 31.550. Just past the 30. I'm gonna go up to 550, so maybe right about here, something like that. And then if I go to the number 8 fish fillet, 28.560. All right, so 28, 560, these are all kind of grouped close together, but that's going to be about here maybe. Number 10, grilled chicken light is 5,300. So that put that here. I might do a couple more. Okay, do a couple more here anyway, because this gets more points. So cheeseburger was 13,320. So that'd be about somewhere around here. Quarter pounder, 21,420. 21, 420, about here. I can kind of see a trend happening. I think we did the Big Mac. The arch sandwich with bacon, 34,590. Looks like there might be a relationship. So 34 and 590 is going to be like up in here somewhere. All right. And so now that I get this idea for what the trend is doing, I see that the trend is going uphill. Okay, so it looks like as the amount of fat increases, so does the number of calories for the most part. And I'm going to make a best fit line that goes through the middle of that data. Okay, and I got to kind of eyeball it, see where it's at. A majority of the lines are kind of coming in one straight line. I'm going to probably go just slightly above it to account for those other marks. That should be a straight line. Okay, so now I got to find the slope. And so when I do slope, don't use your original data points. You want to use spots on the line, okay? Now, I like to look for intersections or halfway points. So it looks like there's an intersection here. That'll be easy to read for data. And then look for some halfway points. Like this is a halfway point. That could work. Or this is pretty close to an intersection, or maybe even here. Maybe I'll pick this one and this one. They're kind of further apart too, so maybe give me a better idea with my data. I don't know. But so this value here is going to be, we always do them from left to right. So this is going to be my x1, y1, and this is going to be my x2, y2. Okay? And so when we do slope, we do rise over run. And it's important to pay attention to what the data is because that's going to tell me what the slope is saying. So the rise, that's the y-axis. Okay, so in this scenario, that's the calories. And the run is the total fat down here. Okay, that's in grams. Okay, so the other thing we say for rise over run, what it really is we take y2, we subtract y1. And then on the bottom, we're going to have x2 minus x1. So if I take my numbers in there, this x1, y1 point would be 10 is x1, and 300 is y1. And then up here at the top, my x2 would be 30, and y2 would be 550. Okay? All right, so if I take my y2 minus my y1, that's 550 minus 300, which would be 250. All right, so I'm going to get 250 on top. And that's calories. And then on the bottom, I'm going to take 30 minus 10. That's going to be 20. So 20 grams of fat. And there's my slope. Now, we can always make this into putting 1 gram of fat on the bottom. Sometimes that's helpful to do if I just do a division problem. So I would do 250 divided by 20, which should come out to be 1, 2, Make sure that's right. Yep, 12.5. And again, that's calories. Calories. That's a C. All right. So make a for every statement. Well, so originally I could have said that there are 250 calories for every 20 grams of fat. Here I can say there are 12.5 calories. Here's my for every part. For every 1 gram of fat. So we're seeing a relationship here. That's the idea of doing this best fit line. It's showing us a relationship between the two variables that we're graphing. Okay? And from that, I can go on to make predictions. It's also important to note when we're making a best fit line, what is the y-intercept? Okay, so the y-intercept is just where does our best fit line cross the y-axis? So where does it hit here? And always ask ourselves when we're checking our best fit line, does y-intercept make sense? Okay, and I asked that question in class today. And because like when we did the volume of water, like we did volume in cubic centimeters and we did volume in milliliters, should the y-intercept be the origin, meaning if one is 0, the other is 0? Okay, and for the volume of water, yeah, probably. If the volume is 0 cubic centimeters, then it should be 0 milliliters, right? Meaning there's nothing in the container, then there would be nothing in the graduated cylinder. Both values would be 0. Here, I'm not so sure because when we're looking at the total calories in the food, calories in food don't just come from fat. We're looking at a relationship. Um, you have other things. You have carbohydrates, you have proteins that add to the number of calories. So there, that's telling us if there were 0 grams of fat, then the food is probably going to have something close to 200 calories. And the 200 calories would be coming from, like I said, carbs, protein. And so that's how we can read the data from the best fit line, and when we can go further and ask more questions with science. And that should have you guys ready for tomorrow. So study up and good luck.